Okay, bilinear transformation method. So the higher filter design. So we already know there are three methods we use: approximate and derivative method, impulse invariant method, and bilinear transformation method. So approximative derivative method, impulse invariant method we discussed in previous videos. Then for the design of low pass filter and band pass filter, the response frequencies are low. So high pass or band reject filters are limitation is overcome that mapping technique that is called as bilinear transformation. So they're saying the two method, approximate derivative, impulse invariant methods for designing low pass filter and band pass filter. Okay, that technique used for approximate detecting and impulse invariant. So those technique is not suitable for high pass and band reject filter. Only low pass and band pass only used that impulse invariant method and appropriate derivative method. But if you go to bilinear transformation, you have to go better. It's suitable for high pass and band reject filter. Okay, so the limitations overcome in the mapping techniques called bilinear transformation. So this transformation is one-to-one mapping from the S domain to the Z domain. So bilinear transformation is a conformal mapping and that is transforming the j omega axis into the unit circle in the Z plane. Only once that avoiding aliasing of the frequency components. Okay, then step to design digital filter using bilinear transformation technique. In the given specification, we find the three warping and analog frequencies in the formula omega 2 by T tan omega divided by 2. So this is a step to design. So using analog frequency, find HFS of the analog filter and select the sampling rate of the digital filter. Call it T seconds per sample and substitute the value as 2 by T 1 minus Z inverse 1 plus Z into transfer function found into step 2. So apply bilinear transformation. Here the example H of S 2 divided by S plus 1 and S plus 2 with the T is equal to 1 second and find it H of Z value. So H of S is equal to 2 by S plus 1 and S plus 2. So substitute the equation of S is equal to 2 by T 1 minus Z inverse divided by 1 plus Z inverse in H of S to get digital form. So H of S is equal to H of S. H of Z is equal to H of S. So we have to put it S of S is equal to 2 by T 1 minus Z inverse to 1 plus Z inverse. So the equation you know that 2 divided by S plus 1 and S plus 2. So you just substitute the value. So instead of S we just substitute this equation and you get the equation like that. So you know that question also the given t is equal to 1 second. So where the t is there, just apply 1 second. So the equation will be like that, and simplify the equation like take that LCM, and you will be get like that, and then simplify the equation, and finally you will be get it h of z is equal to 1 plus z inverse divided by z minus 2 z inverse. So this is nothing but and this is equal to this one for z inverse minus z2, so that is equal to 0.1661 plus z inverse whole square, so 1 minus so z double 3 z inverse. Convert the analog filter system function h of s into digital IAR filter using bilinear transformation. The should have to resonance frequency pi by 4. H of s is equal to s plus 0.2 s plus 0.2 whole square plus 9. Omega c is equal to 3. So omega is 2 by t tan omega 2. So omega c 2 by tan omega r divided by 2. So t value, so 2 by omega c tan omega r divided by 2. So here the simplify the equation, you got the value is t. So using bilinear transformation, this is a formula, we know that. So just apply for the S. So what they already have. So they here the resonance frequency they given. That's why we have find the t value using the t value. Okay, then apply the value, then simplify the equation. You got the equation h of z. Then you have to further you have to simplify the equation, and finally you get the value is H of z equals to 7.4 plus 0.44 z inverse 7 z inverse. So this is the equation, you got the final answer. So this is another example for bilinear transformation. So I use the equation, apply it, and simplify the part, and you will be getting the final answer. Okay. Uh, so this is another example. So they have h of h value. Using that, they find that omega c. Then the formula is there. Apply the formula, and omega c also you know the value. So apply that 0.828 and simplify the equation. Finally, you got it h of z. Okay, this is another example, 1 by s plus 1 whole square. So t is equal to zero point 0.1 second. So this is the equation, then apply it, and t is equal to zero point 0.1 second, 1 by 20, 1 minus z inverse. So apply the equation, and finally you get the value is h of z is equal to 0.047. So this is the value. Okay, thank you.